everybody. Welcome and thank you all for being here. My name is Mehmet Akif Tütüncü. I'm a lead software engineer at I/O, currently working at Rabobank as a consultant. And today I'm here to talk about three of the JVM languages I have experience with: Java, Kotlin, and Scala. And I want to just give you some insights on the JVM landscape that's outside Java, because JVM is not only about Java. And before I begin, who here has worked with any language other than Java on the JVM? So we have some hands. Kotlin? Scala, by any chance? Oh, we even have Scala developers. Cool. So let's begin. I'll try and follow this outline today. I'm going to give a brief background information about my experience and why am I doing this talk. Then go over the current state of the JVM languages, and then talk more about like what people actually do with these languages, and finally some words about my observations about the mindset of developers who use Java, Kotlin, or Scala. Okay, so let's start a bit of a background information about me. I first started with Java, like many other people, back when I was in university. Then towards the end of my university life, as I was already working with Java, I ran into Scala. I got lucky, I guess. Started with a part-time job, switched to Scala, doing full-time Scala, and then after some years during my professional life, I also got introduced to Kotlin, and I always used all these three languages, both in my professional projects, in my hobby projects, in different platforms, in different tech stacks. So I used many different versions of these languages as well, and I got to experience some evolution in the languages themselves. So that's why I thought it could be cool if I make a presentation about the languages and how they evolved over time, more focused on like what they are today. And for the remainder of the presentation, I'm going to talk about these three languages. So let's start by going over the current state of languages, and I'll start with Java. So there's Java 23 as of today, as the latest version, and there is Java 21 with the long-term support, basically. But still, even though these are the latest versions, still some of the older versions, especially some of the older LTS versions, are commonly used. And it is getting better and better every release. They are now following a 6-month release period, and with every release they actually add quite a lot of features. They added a ton of things like pattern matching, records, virtual threads, structured concurrency, string templates even at some point, and then performance improvements and so on. And even though there are ways to write Java and build something other than the bytecode for JVM, like native applications, directly machine code and stuff, it's still the bytecode and the JVM as the main target of the language. So let's move on to Kotlin. Currently there is Kotlin 2.0.21, unless they released another version before I checked. After I checked. It is a really powerful alternative language on the JVM. There are already people working with Kotlin in this room, apparently. It's really concise, it's multi-platform, and it's quite fun to work with. It's their definition, and it's also my experience. And as far as the target platforms go, Kotlin goes beyond JVM. You can write Kotlin and compile it to JavaScript for web browsers, or WebAssembly, I think. You can write native code, you can do iOS, Android, you can do even desktop applications. So it's really more broad in that sense. And then by design of the language, it is designed to be a better Java, because Java back in the days was not evolving as fast as it does these days, and it lacked a lot of cool features that really helped in development. So it was designed as a better Java language, but then with all the features that it supports, it actually has quite well support for doing functional programming as well. So it's a really fun language to work with. And finally, Scala. Similar to other languages, the latest version of Scala at the moment is 3.5.2. They did run into an issue releasing 3.6, so there's a confusion there. And Scala also has a long-term support as 3.3.4. But the thing about Scala 3 series is that it's not a completely migrated thing. There's still Scala 2 series actively being used. It's also a point to discuss within the Scala community. It's again a really powerful language. It's super. It can be super expressive, really concise. It has a great focus on functional programming. It actually brings you the best of both object-oriented programming and functional programming. It is designed that way. It's a scalable language. It's even in the name. That was where Scala word comes from. And it also goes beyond JVM as far as the target platforms go. You can you can compile it to JavaScript with Scala.js or native code. And with this overview of the languages at today, let's try and build an example program, little program to showcase some of these features in all these languages. Let's imagine a program where you have a person data model with name and optional hobbies, and this program will have some people, some person objects, and then we will try and find the person objects that have no hobbies. So that kind of a simple program. I'm going to show examples of this in different languages. I'm going to check if I have my laser pointer here. Perfect. Yes. So let's think about that in Java. So when I said a person with name and hobbies, we can think of a class like this. Because requirements didn't really say anything about changing it, I just went with final variables. And then with this, we can write such a program, right? Just to be able to demonstrate things later on, I kept it as a list of objects instead of list of people, because there are certain features that I like to point out later. But we are just creating a list. We are creating another set for the hobbies, creating some of person objects, adding them to the list. It's really straightforward code. But even though this solution works and it's really straightforward and clear, this is really not the kind of Java that we write today, or we want to see, or we want to work with today, right? So, no. What we can have instead today with the latest versions of Java is something like this, actually. It's much more concise. It can fit on a slide. It can run. This code examples I'm going to show today can be run directly, hopefully, unless I made a mistake. So what's happening here? Let's go over them, right? So there is this record type of classes now. They are designed to be immutable by default, and they are designed to be data containers. So We know our person will contain data of the person and not really any behavior. So we can model that as a record. Records have things called components. So the first component of this record is the name of the person, and then we have the hobbies as a set. But I also marked it as nullable just for better tooling support, because then my IDE will be able to help me in certain situations. Then we have a list of some objects here, and I used list.of the collection builder because, as you may remember from the previous slide, it wasn't that easy to create a list with some predefined objects in it. Recent versions of Java, I believe this has been around for a while now, but allows you to do this. And same goes for the set, and that record class is just a class, so we can use new keyword there. And instead of defining the type, I use the var keyword. Therefore, the type of the variable people there is inferred. It lets me write more concise code. And then I used my good old stream API that got introduced in Java 8, I believe. It's been around for a while, to do some filtering. But there are now more advanced and more new features of Java that I used here. This whole thing after the instance of here is what's called a pattern matching. And I am trying to match those P variables of type object into this pattern of person. I am allowed to do this because I define person as a record, and records have components that can be deconstructed like this in a pattern. And I am using the var keyword here again to avoid typing the types. I am even using underscore, which got recently added. In patterns, you can use underscore to avoid naming the variable. And then I have my guard clause that only if pattern matches will happen. And in the guard clause, I can even refer to P as the instance of person, because I already checked it's an instance of person. And then later here I am going to try and print the name of that person. But what I'm doing here is called a string interpolation. It was a temporary preview feature in Java that other languages already have. It looked a bit quirky with this backslash and curly braces syntax, but that's one of the reasons it got removed from JDK 23. So in 21 and 22, this was this was a preview feature you could enable, but it's now gone apparently. But yeah, this is a much nicer program that we can write with the modern Java. So now let's try and do the same thing in Kotlin. This is the same program in Kotlin, and it in certain ways looks similar to the modern day Java. It has some things going on. I'll quickly go over them. Instead of records, in Java we have data, what's called a data class in Kotlin. It does the same things as Java records, but more. It's again immutable data container for us. Similarly, we can build immutable lists and sets with the collection building functions defined in the standard library of Kotlin. Then Kotlin also supports named variables and like out of order argument passing. So that makes creating a person whose name is Jack with hobbies as null much explicit, so that we also don't mistakenly pass null into the name variable instead of hobbies, right? So there are features like that that makes life easier and avoid mistakes. Here I am calling a custom method that I defined above. I'm gonna talk about that in a second. but what I'm doing is I'm filtering those objects by the type person, and at the same time I'm filtering them by a certain condition. I'd like to point out to how that nullability is handled in Kotlin. So here what I have for the hobbies is a set of string question mark, which in Kotlin is a different type than set of string itself. So it can be holding null values, whereas set of string without the question mark cannot hold null values at compile time. While you're writing, it's not going to be possible to do that. It's really a neat way of handling it. Personally, one of my favorite Kotlin features, to be honest. And when you have nullable types, values with nullable types, what you can do is you can use null safe access methods, operators here. So if hobbies is null, is empty is not going to be called. There's no more null pointer exception because of mistakes like this. And then there's also the Elvis operator, so-called Elvis operator, that can yield a default value if the left-hand side is null. So it's really nice to work with. And there's string interpolation by default. You don't need to do anything. It's really easy to use. There's this it implicit variable name. I'm not giving any names to my lambdas input variables here. And for the filter by function definition, I included it in there to showcase a couple of things. First, Kotlin standard library already provides a lot of useful things. This filter is instance, and filter comes from the standard library directly. This is what's called an extension function, so that even though iterable type does not really have this kind of a function, I am able to call it on my people list object. And it is also inline and stuff, so more advanced Kotlin features there. But you can see it gives us nice tools. Now let's take a look at the Scala version. And this Scala program is also really short. It also really looks similar to the other versions. Instead of record or data class, Scala offers what's called a case class. This is even a bit more concise because you don't need to say val or other things. There are similar ways to build collections. The optionality here is denoted by this type called option. And this is similar to the optional type we have in Java that also got added Java 8. This is basically wrapping one type to denote that it can be some value inside or no value, and it becomes none. So what happens here is similar to the Kotlin example, but Scala standard library contains even more powerful things, and the pattern matching in Scala is also more advanced. And I was able to write something like this here, which is even more concise, as you can see. So I'm trying to match every P object, which is of type any here, to a person, and I'm again extracting their hobbies object. And since it's an option, there is this utility called for all, where I check if option is empty or the content inside the option is empty. So it's giving me the correct type inference as well. I'm returning P when the pattern matches, which is directly an object already. So there's this. There are some directives comments at the beginning. This is also something new in Scala that I wanted to show. It is able to run. You are able to run this code with Scala command line runner directly. So you are allowed to do that with this. So what's the verdict? We saw a simple program written with the more modern features of the languages. So based on this, I can say that writing Scala is writing Java, sorry, is definitely a much better experience compared to years ago. It is gaining more and more features every version, so it's definitely picking up the cool and nice and wanted features from other languages and building it into the language to make itself better, right? So for Kotlin, it's definitely a language that is powerful and designed to be better Java because it supports more features. It's fun to work with. And as I mentioned, my personal favorite is still the null handling in Kotlin. And Scala, for Scala, it was the case that Scala offered many of these features, maybe even all of these features, way before the other languages. That's where some of its powers actually come from. It did string interpolation, it did immutable collections and data case classes even before Kotlin existed, even before those things were never known in Java. Scala did those. So it has its advantages in that way, but there's also this steep learning curve that comes with Scala and also some of the controversial topics. So there's that. It's good to be aware of these differences. So that's what I wanted to say. And now let's talk more about what people actually do with these languages, right? Well, let's again talk about Java. When I'm talking about languages and my experiences here in this presentation, I am going to be focusing more on web development and backend because that's where my experience is. And on the backend, when people use Java, they use annotations in one way or another. And this is actually an example taken from my current project. It is written in Kotlin, so to make it Java, I wrote it in Java syntax, but this is the exact code I wrote and I have to deal with. So, but joking aside with the annotations, what people do on the back end with Java is mostly using some sort of framework, and these are some of the popular ones, and Spring Framework is probably the most popular one. And as I mentioned, they deal with annotations in one way or another. They have other ways of doing things as well, but mostly you use declarative style and you define annotations to basically modify the behavior. But that's also not the only thing that's happening when it comes to backend and Java. It's also really common that people are now doing reactive programming with Java, and these frameworks already support reactive programming. Spring Framework has this web flux module where you can use Project Reactor, monos and fluxes, and do reactive programming. And other frameworks I mentioned here, there are probably more, also support this. And even if you are not doing reactive programming, Java itself became much better. It introduced virtual threads and everything. So even that simple looking and old looking Java code might now run with much more performance, depending on the context, of course, but still. So that's what people do with Java on the back end. What about Kotlin? Well, this was the Kotlin example. So here's the exact same thing. When you use Spring Boot, it also supports doing things in Kotlin. Well, you can have the same thing, but that's again not the only thing that Kotlin developers do. There is another framework. There's another library. I'm not sure which one is the correct word for Ktor, but there's something called Ktor, It is developed by JetBrains, the company that also developed the language. So it lets you write server and client code idiomatic to Kotlin. It has a really different approach. It also goes, I think, a bit hand in hand with functional programming as well. So here's an example that just builds an netty backend server that has routing built in, and it's gonna reply hello to a request to the slash, and it's just gonna wait for the server indefinitely. So it's really easy to get started. It supports more features with more plugins. This routing is a plugin, and then there's another option here called HTTP4K. This is a library, HTTP library, and it is built on this idea that HTTP is actually a function from a request to some kind of response. And that's what you'll be able to see here, that well, my application is this function from request to response, and when I get a request, I build an OK response with this body. So you are able to build that application as a server, and start a server application like that. You are also allowed to create clients and create the requests that you want to send and apply it to the client to get a response. And it works with the same core idea that it's a function from request to response, right? Besides this, on the back end, people who use Kotlin can use what's called coroutines. That's actually one of the more distinguished features of Kotlin language. What it gives you is the ability to do concurrent programming in this async await kind of style. It lets you write suspending functions that can suspend their execution at a certain point and then later on continue from that point. And this is an example I took from Kotlin's own official documentation. And as you can see here, we have a suspending function, and these are the what's called coroutines that I start one after the other. They do work in this concurrent way that when I run the main application here, what do you think will be printed to the screen? Any guesses? Exactly, hello, world 1, world 2, and then done. So it's a really nice way and easy way to get started with the concurrency. There are, of course, more advanced features of coroutines that goes beyond this, and it can get difficult to get it right too. But it's a really powerful tool that Kotlin supports directly. And then I mentioned functional programming. Kotlin even has like additional libraries on top of the really great standard library it has, and lets you do really powerful functional programming things. I don't know if you've been here for the previous talk that talked about functional programming, and it mentioned a result type that looks similar to either. Either is some concept that brings error handling from an exception level to basically value level. You denote your return types with either to be explicit about that your function can either return an error or a value, and that way you need to deal with that possibility of the error later on. It just doesn't throw an exception. And there are, of course, useful methods defined on this type to deal with the error. Maybe convert that to a different thing, or like get a default value, etc. And Arrow is a set of libraries written in Kotlin for doing functional programming. It gives you great tools, and this is just an example of the either here. Now let's move to Scala a bit. So for those of you who aren't familiar with Scala, I also want to talk about the use cases of Scala a bit. Again, we are talking about what people do with the language. So the use cases for Scala are four main use cases are this. It's used on server side. That's one thing. It's also used in data processing, and data engineering, and data science. That's another really common use case for Scala. You can do command line applications with Scala. It's actually possible to write scripts and everything with Scala, and then you can even do front-end web with Scala these days. And again, it's safe to say that there are multiple things to multiple ways of doing the same thing in Scala. That has always been a controversial topic, and that also reflects to what people do with Scala and how they use Scala. There are people who use Scala as a better Java language, better language on the JVM. They use certain features of Scala, but they don't really go deep. There are people who use it as more balanced of object-oriented programming and functional programming. They use more features of Scala, they use the nice parts, but they don't really go out too much of the standard library or the kind of framework that they are using. And then there's purists of functional programming who use Scala, that they usually use more advanced features, and that's usually when you start hearing about monads and category theory and type classes and all that scary sounding stuff. This is where people start using functional effect systems. It's basically a way of making your programs into values. Like you are building your programs from really small pure components and combining them in certain ways into bigger components, up to a point where your entire program is one value that gets run at the end of the world. That's the term they usually use, which is your main method. So let's see some examples of that. So this functional effect system, there are also many implementations of this in Scala. That's another topic where there are multiple ways of doing the same thing. And there's this library and also set of libraries called cats, and there's an effect implementation called cats effect. So that's an example of cat's effect here. Let's start by looking at here this method called long operation. This is essentially, effect is essentially a way of wrapping your computation, some kind of computation, so that it's not computing, but you are describing how to compute. So this long operation returns an IO of int, which means it is going to eventually, when run, going to produce an integer value, and it may fail or it may do other side effecting things, but it is eventually a program describing the computation of an integer. So that's the small part here, which contains even smaller parts. This comes from the library itself, containing the logic of sleeping for 1 second. And then there's this operator in between, which is actually a method. Scala allows you to have such weird looking methods, and you can call the methods with this spaces. There's no dot around. It's a syntax thing in Scala. So what happens is this method is an alias for flat map method, where you would run one effect, and then the other effect. It's basically one of the core combinators in the effect systems, and it lets you run things sequentially. That's one of the core ways we combine smaller things into bigger things. That's usually how the programs in Scala are built, and this is sort of like the main method of this program, the run effect, the run method that runs the main effect. And what happens here is we are getting one of those descriptions of computation, and then there's this start method call on them that gives us what's called a fiber, and this is a demonstration of that concurrent ability of the functional effect systems. So the idea is simple. Idea is describing instead of doing, so that you have a value that you can combine to build bigger programs. But it is so convenient that you can also implement certain behaviors and really different ways of combining these into bigger programs, that it also has features to do concurrent things. So it starts to concurrent operations, then waits on the results and prints the results. So that's basically what's happening here. And this for and yield syntax is again a syntax feature of Scala, basically easier way of writing flat map chains, because we want these things to run in sequence. So that's an example of how functional effect systems can be used. Here's another example that uses another library called Zio, which is another powerful and really popular functional effect library. It also has its own like small ecosystem of other libraries that integrate well with Zio, and Zio HTTP is one of them. So again, this is a server application. It looks kind of similar to what we had in HTTP 4K example. That's kind of intentional, because this idea of an HTTP application being a function really applies in a language that supports functional programming well, in Scala. So there's actually an HTTP4S library that does the same thing, and this Zio HTTP is also doing a similar, it's working in a similar way. So we are building a server application that has two endpoint to route definitions, basically, and these are all sort of effectful things that they return values using functional effects of Zio. And here is just a way to build this server and run the application. So what Scala people usually do, they use functional effect systems in this way. So this is actually my last slide, and this is where I want to spend some more time. So I wanted to give you some insights about my experiences and the languages themselves, but I wanted to also compare them in certain ways, and I came up with this alignment for the languages. So on the left-hand side, I put things, I put certain things, and on the right-hand side I put certain things. Then I also align the languages according to this. So let's go topic by topic. So compile time versus runtime is one topic that I want to discuss. And here what I mean is what developers usually do and at what time. So when I'm writing a program, what kind of things happen at compile time and what kind of things happen at runtime. This is really fundamentally different in the mindset of developers using different languages. So while Java developers tend to rely on the runtime a lot, Scala developers really don't. Scala developers rely on the compile time as much as possible. There are, of course, advantages and disadvantages to each choice here. I'm not going to go into that, but I'm going to try and give like more examples of why this exists. So for Scala people, preferring compile time over runtime is a thing because the language itself has features and has abilities to provide this. Instead of relying on runtime and reflection, for example, to, I don't know, serialize an object to JSON, in Scala, what you usually see is there is a separate object that's responsible to serialize to JSON, and that needs to know the schema of the object that it needs to serialize, basically. And that schema is either something you write yourself or you have it generated, but it is generated at compile time. There are macros and compile time features that Scala supports. So Scala people really tend to do things at compile time, because also Scala compiler is a more powerful tool than Java compiler in certain areas because of the features that Scala offers. So while Scala is at the compile time side, Java is usually at the runtime side, because many things happen at runtime. We have exceptions that are really common in our development that all work at runtime. We have reflection-based stuff that all work at runtime. We have annotations that modify the behavior at runtime, and so on. So there's this separation in that sense on this topic. And at this topic and also at other topics, I observed that Kotlin is actually somewhere in between, because it is trying to do things at compile time too, but it is also able to use runtime. So let's move on to the next topic of explicit, being open, being discoverable, versus things being hidden, things being auto-configured for you, things being magical, sometimes even I'd like to call it dark magic. And that's also a separation between these languages. So in Java, we tend to have things hidden from us, and we tend to have things configured automatically for us. This is especially true in frameworks like Spring Boot, for example. Have you ever recently, at least, created an HTTP application, a server application from scratch? Anyone? Yeah. With Spring, for example, what you do is you go to start.spring.io, you pick a couple of options, and it gives you some code that doesn't really contain much code. It's just some dependencies and stuff, and suddenly you have a functioning web server application that has a ton of features, and all those features are configured for you in a way that you don't see, in a way that you don't know or necessarily understand in many cases. You want to have more functionality, add another dependency, everything works. That's usually the way I see it, and it can be beneficial, of course. As I mentioned, there are advantages and disadvantages to this, but it can also be a really pain point for you if you don't know how certain things are built or configured. You may have a hard time. Whereas on the other side, things in Scala, based on my observation, are really explicit and open, and more importantly, discoverable. So you have an application that starts somewhere. If you start going through the code, you'll see that any kind of component that it uses gets created somewhere. You see it in the code, you see it, and you write it in your own code, even though that might look like a lot of code that you don't need to write. It gives you that ability to be open about this and be discoverable. So let's move on to the next topic of type safety versus reflection. This is, again, similar to, related to the first topic. And again, there is this separation of Scala preferring more of the type safety and things being known at compile time, versus Java being more flexible about this and is okay with knowing things at runtime in many cases. And then there is this immutable versus mutable comparison between the languages. It's really typical for a Java application to create an object and then set certain properties on that object and then use the object in some way. That's actually how Java beans work, and that's how basically this enterprise industry around this works from a top level. So there is this mutation by default that also comes from the principles of object-oriented programming a bit, whereas Scala and also Kotlin is the same. Other languages came up and said, okay, things being mutable by default does not really make sense in most cases, or I don't know, it makes things complicated in most cases. So things should be immutable by default. So they came up with that decision, and Scala is definitely one of them. And as I mentioned, it did those things earlier than the other languages. And the collection library that exists in the standard library in Kotlin and also in Scala promote this immutable versions by default. There are utilities like case classes and data classes and singleton objects and using variables, the immutable variants like val, or actually it's val in both languages, by default, so that it promotes immutability. It usually helps you write safer code. It makes it more explicit that when you want to change something, when you want to mutate something, you do it knowingly. So there's that separation, and again, Scala and Kotlin is on the left side, while Java in certain cases promotes mutability. But it is also learning from these other languages, and that's why we now have records, and that's why we now have this collection builders that give you an immutable object by default. So that list off that we saw, it gives you an unmodifiable list. It's not ideal because it's still a list and you get to call add method on it. But when you do at runtime, you get an exception. So what would happen in other languages, actually what happens in Kotlin in comparison to that, is that that list of builder gives you a list which is not a mutable list, because mutable list is a different type and it has a different builder. If you want to build a mutable list, you are explicit about that. And because of the separate types, you also have this ability to avoid that mistake. That immutable list does have an add method, but it doesn't modify the contents. It actually gives you a new list, so you keep the immutability. Whereas the mutable list interface gives you an add method that actually modifies the contents. So there's a really distinct separation there. And lastly, the functions and compositions on one side, and going more towards design patterns instead on the other side. So with Java, it's really common to hear the words design patterns because it's really common that people go for design patterns. That's how Java language is taught in many cases. That's what other people are doing that use Java. It's not necessarily a bad thing, but it requires you to learn those things, whereas on the other side we have functions and ways to compose those, and that's what gets taught, and that's at the core, and that's the style of programming they do when you write Scala or Kotlin. So I wanted to talk about my experiences on this and kind of give you the picture, because this is mostly something that people don't really think about, and I wanted to highlight that. So that's the end of my talk. Thank you very much for listening.